Hey guys, how you doing? Doug back again, Recording Connection Audio Institute. We're going to take a look at what digital distortion actually looks like, what it sounds like, become familiar with, kind of the concepts and around it. Obviously, distortion is something we're trying to avoid because it's not a pleasing sound. But what I did on this example is I slammed the inputs to my preamp, and I have a preamp that's connected to an interface. So I'm actually slamming the inputs on the interface. The interface is what turns my analog signal into a digital signal. And when you slam those inputs, a curious effect takes place. But let's take a listen firstly to what it sounds like.
This is a test in digital distortion.
So 100% ridiculous. Let's now zoom in at the waveform and take a listen to and take a look at what those waveforms are actually doing. So here's a regular waveform, and this is actually the room tone. I have the input so loud that the room tone is audible, very audible. So this is, pretty much what we're used to here is, normal waveform. There is a compression rarefaction, and we can see kind of, what that looks like. Then we get into me, starting to talk and sound like a complete moron. And then we actually see the waveforms increase in amplitude. The way that digital distortion works, because if you'll notice, I'm going to play this again, but this time I want you to watch the meter. It actually doesn't distort, so let's take a look at that.
This
up to a point is stop moving, right? So what that really means, and what's happening here is because the digital world has a fixed amount of amplitude values, right, that are determined by the bit depth. You remember that from digital audio. The bit depth acts as like a grid, right? And what happens is we sample based on our sample rate points on that grid. We can't sample anything that's not on that grid. This particular audio sample is 16-bit audio. So once we exceed the amount of amplitude values for that 16-bit audio, you'll see what happens here is it is unable to be charted, so it goes to the nearest possible value. So what that looks like is, like in the case of this, it bottoms out, right? So it cuts off the top portion of the waveform, and that's why we get that grainy sound. If you'll notice, what's kind of happening here is similar to when we talked about sawtooth waves, right? Sawtooth waves top out, and they have that distorted kind of quality, right? So what's happening here is the amount of amplitude that is going into the device is unable to be converted, naturally, because it's exceeded the possible amplitude values, okay? And the result is it's distorted sound. So typically, again, distortion is something we try to avoid, but I do want to remind you that there are no absolute rules in audio, right? This sound could be something that you're going for. Now, it's probably not the best thing you could possibly do to your gear, but at the same time, you can possibly use this sound if it is in a song that requires it, or you're doing something like that. You can slam your inputs and you can get that sound that you're looking for. There are other ways to duplicate this sound as well, using plugins and things like that. But this has been a lesson in digital audio, and just showing you exactly what that distortion looks like. And as always, stay tuned. More to come, guys. Have a good one.